Hello learners, in this lecture we are going to learn about Pearson's correlation coefficient, which is a mathematical measure of determining correlation between two variables. Carl Pearson's correlation coefficient is also known as Pearson's product moment correlation coefficient. It was introduced by Galton in 1877 and developed later by Carl Pearson in 1895. The coefficient of correlation is a number which indicates to what extent two variables are related. This is the most popular measure of correlation for measuring the degree or strength of linear relationship between two variables. Pearson's correlation coefficient between two variables is defined as the covariance of the two variables divided by the product of their standard deviations. Now look at the assumptions of Pearson's correlation coefficient. The first one is the underlying relationship between two variables is linear, which is the assumption of linearity. The second one is the variables under consideration should have a bivariate normal distribution. So, before using Pearson's correlation coefficient formula, we have to see that whether the assumptions or requirements of Pearson's correlation coefficient are fulfilled or not. The Pearson's correlation coefficient is denoted by R or Rxy. If we want to measure the relationship between two variables x and y, then we can use this formula, which is shown here. Here in the numerator you can see that there is summation of xi minus x bar, yi minus y bar, where x bar is the mean of x and y bar is the mean of y. In the denominator you can see that there is square root of summation of xi minus x bar whole square into summation of yi minus y bar whole square. There is a simplified form of this formula. The simplified form of this formula is derived from the main formula by some algebraic manipulation. You can use this simplified form for further mathematical calculation of Pearson's correlation coefficient. Now, what are the properties of Pearson's correlation coefficient are? Pearson's correlation coefficient lies between -1 and 1. It is symmetrical with respect to x and y, that is, Rxy equals to Ryx. This implies that we can interchange x and y. Pearson's correlation coefficient is just a pure number and it is independent from the unit of measurement of x and y. Now look at the interpretation of Pearson's correlation coefficient. If R equals to +1 or -1, it means the sample points lie on a straight line. If R equal to +1, it means there is perfect positive correlation between the variables. If R equals to -1, it means there is perfect negative correlation between the variables. If R equals to 0, it means there is no correlation between the variables. If R is near to +1 or -1, it means there is a strong linear association between the variables. This implies that there is high degree of correlation between variables. If R is small or close to 0, it means there is low degree of correlation between variables. Now, if we want to see the strength of the relationship between the variables, we can observe it from the degrees of correlation. If R equal to 0, it means there is absence of correlation. If R equals to +1, it implies that there is perfect positive correlation, and R equal to -1 implies that there is perfect negative correlation. If R varies from +0.75 to +1, it means there exists high degree of positive correlation. Besides, if R varies from minus 0.75 to minus 1, it implies that there exists high degree of negative correlation. If R varies from plus 0.25 to plus 0.75, it means there exists moderate degree of positive correlation. On the other hand, if R varies from minus 0.25 to minus 0.75, it implies that there exists moderate degree of negative correlation. And finally, if R varies from 0 to plus 0.25, it means there exists low degree of positive correlation. Besides, if R varies from 0 to minus 0.25, it implies that there exists low degree of negative correlation. Now, what is the coefficient of determination? The coefficient of determination is nothing but the square of the coefficient of correlation. It is the measure of the strength of the relationship between two variables. Coefficient of determination shows the percentage of variation of one variable which can be explained by another variable, and it is a measure for the goodness of fit for lines passing through plotted points. The value of determination coefficient lies between 0 and 1. Suppose we have a value of R which is 0.9, then the value of determination coefficient will be R square, which is 0.81. If we want to interpret the value of coefficient of determination, we will get this as R square equals to 0.81. This would mean that 81% of total variation in Y can be explained by X. Now look at the merits and demerits of R. The degree of correlation and direction of correlation is summarized in one value in Pearson's correlation coefficient. Pearson's correlation coefficient gives us exact measure of degree of association. It is independent of units of the variables. There are several demerits of Pearson's correlation coefficient. They are: the value of R is affected by extreme values. Calculation process of Pearson's correlation method is long, tedious, and time-consuming. This method is used only for those attributes which have quantitative measurements. When the population is not normally distributed, or when the shape of the population is not known, then R may be underestimate the relationship between the variables.